We're going to look at lessons 35, 36, and 37. And to start in 35, there's one thing that we're going to look at here, and it is how to find a number that is 2/3 of the way from 3 and -7. And so whenever you see this word problem, you obviously need these three numbers. But this is the formula. And what you're going to do is you're going to take the initial number plus the distance times the final number minus the initial number. Now the distance is 2/3 of the way. The initial number is 3 and the final number is -7. So we're going to take 3 plus 2/3, parentheses, -7 minus 3. So you end up with 3 plus -20/3, and 3 plus -20/3, you can make that 9/3. It becomes -11/3. So this is the number, -11/3 is the number that is 2/3 of the way from 3 and -7. The next thing we're going to look at is something from lesson 36, and it is the boat and the river problems. The boat and the river problems, it can also be airplane in the air. It is simply rate times time equals distance, except for the rate has the factor of the water. So you have the speed of the boat plus the water if you're going downstream, the speed of the boat minus the water if you're going upstream, and you're still time. So this is the rate times time equals distance. Same thing. If it was airplane, speed of the plane minus the wind, or speed of the plane plus the wind. Same thing. And you simply got to pick out stuff and solve for that. All right, we're looking at the example on page 259. It says, one day Selby found that her plane could fly at 5 times the speed of the wind. So her plane, so this is an airplane instead of a boat. Same thing, no big deal. So instead of a B, we can put a plane. So her plane could fly 5 times the speed of the wind. So in place of P, we're going to put 5 times the speed of the wind. And of course, you'll have to add the wind and subtract the wind from each of these. Then it says she flew 396 miles downwind. So 396 miles downwind in 1 hour more than it took her to fly 132 miles upwind. What was the speed of her plane in still air, and what was the speed of the wind? So they want to know the rates. And the time thing that they said was that she flew half an hour more downstream. So you got time downstream equals time upstream. And these obviously should have had that. Except for the downstream was more, half hour more. So you can put plus a half to go upstream to make it a true statement. So in place of TD, I'm going to put that. Now we can begin to solve for this. This is 6W, it's 4W. So you get 6WTU plus 6, or it's a half, so it's 3. 3W equals 396. Right here you get 4WTU equals 132. So you divide by 4, WTU, even though it's 2 variables at once, equals 33. And so you could plug that 33 back in, because that's WTU, which really didn't solve for anything, it's the combination. You can plug it in right here. So 6 times 33 gives you 218. 218 plus 3W equals 396. Then you subtract 198 both sides. We get 3W equals almost 200. Oh, it's 198 again. Divide by 3, divide by 3. W equals 66. Okay, so now that we have W, that is the speed of the wind, and you simply multiply 5 times the speed of the wind. So then you get the plane, the wind is 66, the plane is 330 miles per hour. This is miles per hour also. In lesson 37, we're going to look at a concept that uses the distance formula. And you can't just plug into the distance formula and get what you need out of this, but the distance formula is this right here. What we're going to end up doing, whenever they say find the equation of the line that is equidistant from these 2 points. They want to know the equation of the line that is equidistant between these 2 points. And the way that you do it is you take one distance formula and another and set them equal to each other. When you do that, you're going to plug one set of coordinates and x and y into one of them, and the other set of coordinates and x and y into the other one. And then when you solve it all out, you're going to get a slope-intercept form of what that line should look like. So what we're going to do is we're going to take the square root of x minus 4 squared plus y minus 2 squared equals the square root of x minus negative 2 squared plus y minus negative 3 squared. That's squared on the outside. First thing you do is you square both sides. When you do that, it simply eliminates the radical. And then you end up bringing this down. I'm going to write it twice because whenever you square a binomial, remember you're really multiplying the twins. This is not a paper saver. Okay, when you multiply this one out, you get x squared minus 8x plus 16. You get y squared minus 4y plus 4 equals x squared plus 4x plus 4 plus y squared plus 6y plus 9. Now, obviously, the squares all are going to cancel when you add them to each side. You're going to get 20 negative 8x minus 4y. Let's make that better. So all that is done equals, we get 13 plus 4x plus 6y. Bring all your y's to one side. Bring the y's over here. You get negative 10y. Bring the x over here. You get 12x. Minus 20. You get negative 7. Divide everything by 10. Negative 10. You get y equals negative 6/5 x plus 7/10. That right there is the equation of the line that is equidistant from the points 4, 2, and negative 2, negative 3. The last one is the midpoint formula, which is fairly easy. Pretty sure you have an app for this in your calculator. We can look at it in class. But the way this works is the midpoint is x1 plus x2 divided by 2. Midpoint of y is y1 plus y2 divided by 2. Obviously, this is the x and the y, and the x and the y. So you take negative 2 plus 4 and divide it by 2. You take 6 minus 10 and divide it by 2. So this is going to be 2 divided by 2, negative 4 divided by 2. You get 1 and negative 2. So the answer is 1 comma negative 2 is the coordinate that is the midpoint of those two. Not a difficult task. And that's it for lessons 35, 36, and 37.